Hey, it's Mr. O. Welcome to One-Dimensional Kinematics. What can we measure about motion? Well, we can measure how fast you're going, how far you're going, and how long it takes you to get from A to B. And then also, of course, whether you're always going at the same speed or whether it changes. Let's say you want to go from Dallas to Chicago, and you ask Google Maps or something, and it's telling you that from Dallas to Chicago, that's 1,481 kilometers. And if you get some more information, it also shows you the route. So that could be looking something like this. So here it is, your 1,481 kilometers. However, if you ask a different map, it might be telling you a different number, like 1,295. Well, the difference is that that would be a straight line. Of course, if you're driving there with a car, you can't just plow through your neighbor's backyard and cross rivers nilly-willy. You have to kind of stick to the roads and the bridges and so on. But let's say if you take your private jet, if you have one, if not, become a physics teacher so you can buy one. You can go in a straight line directly from Dallas to Chicago. So those are two different numbers then. So what do we call the difference in that? And of course, it's physics, though there's two names for it. We call the way that you go, like with your car, the distance. So a distance measures how far an object travels, and it takes the entire length of its path. So every step of the way counts. For example, if you go from place A to B, but again, you can plow through your neighbor's yard and crawl over fences, but you have to kind of go down the road, up the road, and then over to your friend's house who lives at B. Then that's your distance, 3 kilometers. So you go 1 kilometer, let's say east, 1 kilometer north, and then 1 kilometer west. Your distance was 3 kilometers. It doesn't give me any information about which direction you're going. Actually, I just gave you that, but let's just say you don't have that. So you go 1 kilometer in one direction, 1 kilometer in another direction, and then 1 more kilometer in some other direction. So that's your distance. Distance is called a scalar because it's not concerned really about which direction you're going. And the symbol for that is small d, not big D, but small d. And the unit is in meters or some derivative of meters, kilometers, centimeters, nanometers, and so on. Depends on if you do biology, chemistry, or physics. Physics, we like the big stuff. Okay, so now we know the distance. So what if we could go a straight line? Let's say you hitch a ride on your drone or something. You go directly from A to B, and you know in which direction you have to go. That would be a displacement. How far are you now that you are in B from A, from where you started? So how far is your ending position from your beginning position? And the ending position is exactly 1 kilometer north of where you started out, and we call that displacement. And that one is a vector because it has two things. It has magnitude, how big, in this case 1 kilometer, and it has direction, in this case north. Now, can displacement be the same as distance? Well, it could be, but that depends on which direction it's going. So if you go a straight line and you happen to go in the same direction, then your distance would be the same as the displacement. Otherwise, it is not. Can distance be longer than displacement? Absolutely. If you go a few detours like you did on the first picture, you went over to the right, up, and then left, your distance can be longer than your displacement. Can it be shorter? Absolutely not, because displacement is already the shortest way you can go because it's a straight line. So distance can never be shorter than displacement. The next two words we're learning are speed and velocity. So speed, you're probably familiar with that. If you drive any kind of vehicle or been in a car, it's got a speedometer, right? Tells you what your speed is. And if you don't stick with the laws, maybe somebody will pull you over and tell you that your speed was just a little bit too much. So speed measures how fast an object moves. What do we need to know how fast an object moves? Well, we need to know first how far it went and how long it took to go there. So for example, if I go 10 meters to the other side of this classroom and it takes me 2 seconds, then I can tell you how fast I was. So 10 meters over 2 seconds, that's 5 meters for every 1 second. So in 1 second, I go 5 meters. That's 5 times a meter stick, which is about, well, as long. What if I took my sweet time and I go those 10 meters in 4 seconds? Now I'm only half as fast. I'm slower because I took more time. So you see, the formula for speed would then be distance over time. We do use v for velocity, usually, because we don't usually calculate speed. And the units are meters over seconds, because distance is measured in meters and time in seconds. Speed is a scalar because it's based on a scalar, which is distance. So it doesn't concern itself what direction you're doing. Your car does not tell you in which direction you're driving. Well, maybe if you have some very modern car, it has a built-in compass or something, it might tell you, but your speedometer doesn't tell you. A speedometer just tells you how far you are right at this moment, so it gives you instantaneous speed. Now velocity actually measures your displacement over time. So how far was it to get from A to B? And then in what time did you go there? We do use v, meters per second is the unit. And it is a vector because it is based on a vector. And that means we can have some information about the direction of our velocity. Let's say here's your house, and in front of your house is your car. Let's make your car hot pink because why not, right? So here's your car. And let's say this is the direction to your favorite shopping mall or something. And we call that the positive direction because of your favorite shopping mall. The other direction, on the other hand, that's where, I don't know, the dentist maybe or something. So dentist is not the positive direction. Dentist is the negative direction. So if you're driving to the right, then you have positive velocity because you're going in the positive direction. Maybe 5 meters per second. But if you're going the other direction at the same speed, you have a velocity of negative 5 meters per second. So which one's faster? Well, they're both the same. They're the same fast, but they're going in different directions. So that negative or positive in front of the number, that's not how fast you are. That tells you in which direction you're going. So velocity tells you in which direction you're going. Positive velocity, you're moving in the positive direction. Negative velocity, you're moving in the negative direction. That's it. Join me again for acceleration on the next video.